To talk about the waves of technological change, I'd like to bring up Brian Matthews, who's Autodesk's most prolific trend surfer. Brian.
Thanks, John. So I want to take John's thoughts about strategy and relate them to technology. And so what we need to do is see what are the trends. What are the technology trends that create an opportunity for strategic separation? Now, if you think of any really big technology disruption, it can create huge opportunity, but it can also create huge headaches. And that's going to come up later in the session when we get to our panel, where we're going to talk about some of the headaches and how you actually get a culture of innovation and bring that change into your company. I'm really excited, though, in the role that I have as Vice President of Autodesk Labs, because we are seeing not one technology disruption. We are seeing 5 major disruptions in the design industry, all happening at the same time. I mean, this has never happened in my entire career, this much opportunity and change. And, of course, headaches go along with it. So I'm going to go through these 5 technology trends in a little while. But I want you to be careful. You know, if you think of a technology disruption, it's very easy for us to look at a new innovation and say that we understand it, say that it's something we already know. I mean, this is a phone, for example. Is this a phone? Okay? When smartphones first came out, people felt they understood that. It's a phone and it does more. Just like any kind of operational efficiency, things continue to get better over time, and so do phones. But as you all know, this turned into a major platform shift. A lot of change here. We have TV. Is this TV? Okay? So you could see that these technology disruptions can take you by surprise sometimes if you're not really paying attention. So let's follow the trends. Now, if you think of how most companies follow trends, it's what we call the pragmatists. And where most people start investing in a new technology trend is when something first becomes expected. That's when a customer asks for it. So customers come along, start asking for some new technology or new process, and companies start to invest at that point in time. And often they feel that they're ahead of the curve. Okay? And eventually, of course, people invest and it becomes required. But the real opportunity for competitive separation is not this curve, not the adoption curve. The real opportunity is this curve. You have to be investing ahead of when customers are asking for it, of when it's expected, because that's the point at time when your competitors are least able or least willing to take advantage of a new technology disruption. And in fact, I would say you need to start working or thinking or exploring an idea even before that. Because if you're going to start investing when something is newly possible to get that maximum separation, you have to be working with something when it's still impractical. And that's the difference between what we call an invention, something that's possible but not practical, and an innovation. And your job, if you're going to use technology as a way to get separation, is to innovate. So let's get to these 5 major technology trends. The first one that's happening that's really creating a big shift is reality capture. If you think of reality, reality is complicated. If you wanted to change a sidewalk, put a fiber optic cable here, how would you do that? You'd use a CAD tool. You'd create a digital model. You'd make a plan. You'd coordinate lots of people with that. But the real truth is the CAD systems start out like this. As complicated as reality is, they start out like this, a white sheet of paper. It takes tremendous amount of effort and time to get a detailed CAD model to make a great plan, and a lot of times you're not going to do that. You're not going to make as sophisticated a model as you would want. But there's a change happening, and that's around reality capture. There's a new class of devices that are disrupting the industry. This technology has been around for decades, except it costs an enormous amount of money. These laser scanners capture 3D geometry automatically, millions and billions of points in a very short period of time, but just a few years ago they were $120K. How much can you get this for now? About the price of a TV if you're in the manufacturing space. Okay, people can do this at home now, right? Or about $35K for a terrestrial laser scanner. A 60% price reduction per year for the last several years, and we don't see this trend stopping anytime soon. That means we can capture reality, millions and billions of points, very rapidly and easily. Now, this is just last year. This is the kind of technology that you would see in a CAD product, looking at laser 3D point clouds. And this is how the technology, just in a short period, is transforming. Look, it's a solid. It's a real object. It almost looks like a CAD model, and it's coming straight from the device. Each one of those tags is a separate scan of millions of points. This is a massive data set. In just a few hours, you can digitize an entire city down to the millimeter, and you can view it as if it was a solid CAD model. But it's not just looking at it as a reference. You can actually use these point clouds now as geometry. Here I am taking a lighting fixture, copying it, moving it, repositioning it, doing things in the 3D point space that I would do normally with a traditional vector-based CAD product. So that's going to create huge change when you can work directly with point clouds, and you don't need to use CAD for a lot of the things you did before. Okay, that's an opportunity. But reality capture goes beyond that. Sometimes you will need a CAD model. What you see here is technology that's coming out, which is taking all of those laser point clouds, and the computer's automatically recognizing shapes. The same way OCR can scan a paper document and turn it into a Word document, you can scan a 3D object and automatically get a BIM model out of it, or get a civil model. You can see the computer is automatically recognizing the different cars and trees and shapes in this model. Now, that's at the very large scale with laser scanners, but there's also technology for other industries to scan things at a very small scale. This is a Brdf scanner. It scans about a square centimeter of material, and what it can do is generate 1 square centimeter, about a terabyte of data. Okay? And what you can do with that, if you're in the media and entertainment or visualization industry, is you can get materials that are very lifelike. If you think of wood and how light interacts with the veneers and the finishes and the subsurface scattering, you can get materials that are very lifelike. Now, which of these two images is real? How many say the one on the left is a real kitchen? How many say the one on the right? It is the one on the left that's real. But that one's been photoshopped, and it has show production lights out the windows there. So the one that's actually more physically accurate, based on Brdf scans, is the one on the right, if you were to actually build that kitchen. Now, if you look at the movie industry, Tron, for example, they made Jeff Bridges 30 years younger, and they had to do that reality capture on an actor who was moving. And the technology for reality capture of moving things, such as in the manufacturing space, has been around also for about a decade. The problem was the price point. This is over $1 million kind of setup here. It hasn't been democratized. But we're starting to see even that technology get democratized. This is the most successful consumer electronics device in history. It sold more units in its first 6 months than any other consumer electronics device. You can get it for 99 bucks, and it generates a 3-dimensional point cloud in a 60th of a second of whatever you put in front of it. That can be a real game changer. We're going to see a lot of innovations around that. But I'm here to tell you that there's technology today that's going to change this reality capture even more. It's $0. It's the phone that's in your pocket. It has a camera, and with that camera, we could take a bunch of pictures, let's say in a factory, and we can get automatically a 3-dimensional model of that. So reality capture is certainly a big trend that is going to change things. Here you can see the mesh model of that data. And I'm going to show you a video now that was captured just from photographs. So we took some tourist photographs. People who are in France went to Notre Dame, took some photographs, and there's technology in the cloud now with some processing that made this 3D model automatically. No human intervention whatsoever, just from a series of 18 photographs. Okay? So the next time you're at a building site, you got a pile of dirt, and you need to compute its volume. You've got a factory, and you want to compute the distance between something and clearances and so on. That technology is rapidly improving. Now, if we want to do this at scale, okay, these are drones. This uses a lot of the similar technology that the military uses in Afghanistan. These are automated drones. They fly themselves. They can carry a 5-pound payload, and that can be a camera. You can use that camera to make a digital model of an entire city or a block in a matter of hours. But this, too, has been democratized. It's down to a couple $100 at the airport gift shop. Okay, I saw one on my way out here. Now, notice at the front of that is a camera. That camera can be used to capture reality now. Now, at Autodesk, we've captured reality with one of our office buildings. This is our 210 King Street. We wanted to understand how LEED buildings perform, why they don't perform as designed, mainly because the occupants don't behave the way we expect. So we captured reality, but not just the geometry reality, we captured other forms of reality with lots of analog to digital sensors. Humidity, pressure, presence of a person at a desk, how much power a particular electrical socket is reading. We put sensors throughout this entire office building. Every single cubicle had this stuff. We went into the mechanicals of the building, the HVAC system, the elevators, everything's got a sensor on it. This is a live building, and we can do simulations and dashboarding of that and see how the building is performing and compare that to simulation to improve it, to improve these green building standards. Again, this is reality capture, not just as geometry, but reality capture is capturing analog data. And that is being democratized as well. There's a company, Dust Networks, who makes this little chip. This chip has the ability to create its own power through parasitic vibrations. It's got a piezo device in there that when something vibrates this chip, it makes enough power to operate it, and it can transmit analog data, pressure, vibration, sound, temperature, and so on. It's so cheap you can pour this into concrete. So imagine smart bridges, smart buildings. You've embedded it into the fabric of a machine, for example, for a couple pennies. And that allows us to capture reality at a whole new scale. This is also being done at miniature scale, at the nano level. Just a few years ago, the Human Genome Project, it cost about $3 billion to sequence the first human DNA sequence. Today, it's $199 bucks. You can have it done for yourself. $3 billion just a few years ago. So the ability to capture reality is a major trend that's happening. The next trend is the result of that. What happens when you have all of this reality captured? You result in massive amounts of data. And so what are you going to do with that data? It's getting to the point where we can't have all of that data on our laptop. You're going out to a construction project, you're laser scanning it every single day. You've got schedule data, you've got cost data, all of these different types of data are coming together, especially those laser scans. There are billions of points. If you scan once a day, every day of the project to document it, that is a massive amount of data. But there's also ground-penetrating radar data. There's rainwater runoff data. There's climate data. There's tremendous amounts of data. Now, we're seeing this trend towards information models, whether it's for digital prototyping or for BIM, bringing all of this data together. But again, the data sets are growing faster than hard disk speeds are. And that's where the cloud is going to be a solution. We can use the cloud to organize large amounts of data and relate them to other, but more importantly, turn data into information. Things like intelligent search technology. You've seen what has happened with Google with text search, but there's other forms of search, parametric search, visual search, okay, turning this raw data into information. The amount of information out there for a single hospital is this. Okay? This is just the mechanicals in a single hospital. But we now are seeing the technology where we can work at city scale. That building you're seeing there and the infrastructure beneath the building and in the city, we're viewing this at city scale. So if I go into the basement of that building, I can see the heating and ventilation pumps that are all underneath this thing. That isn't just the shell of a building. Every single desk is in that model, but we're working on it at city scale, in context. Okay, so we're going to see a massive explosions of data sets. Now that was game graphics, but I think in the near future, this is going to be possible. Parsons Brinckerhoff did this as a visualization of New York, and instead of calling this BIM, or Building Information Model, we call this BAM, or Big Ass Model. And that's what the cloud is going to give you. You're going to have always-on access to big-ass models and integrate all of your data there. The only thing that you have now is a problem is, how do I work with that data? If I have all my applications on my local machine here and I want to do some processing on that, I can't pull down the entire city worth of data. I need to either pull down the parts that I need or have just-in-time delivery of data, and there's people working on that trend as well. But there's another new technology that's coming out, which you probably already use. It's an innovation, but it hasn't been applied to this industry. How many of you have Netflix? Probably fewer now after all the debacles they've been going through, but they were trying to play a strategy. But many of you have streamed video over the internet, and it can be very high quality, high definition video. The problem is that it has high latency. Now, there is new remote desktop technology that's on the market that can run an application in the cloud and send the video of that application down. The keyboard and mouse clicks go up. It remotes your desktop. It's like having a 1,000-mile long video cable. The problem with most remote desktop technologies like GoToMyPC or ones like that, or they have huge latencies involved. You move the mouse, it's a quarter-second round-trip time. But there's new technology that's just hitting the market now that has 10 milliseconds of latency. That's less than the refresh time of a frame on a monitor. So now you can't tell the difference between running an application over the internet 1,000 miles away and running it on your own desktop. And the importance there is that cloud data, because now the compute power can be right next to where the data is, massive data sets, and that's going to change what we can do when we do design. The next thing, after you have this data that's been captured from reality, you've centralized it in the cloud, is we need to do some compute on it. And we use this thing called infinite computing. Many of you are familiar with cloud computing. We use a different term called infinite computing because we make a little bit of a distinction. Now, you probably all know of the cloud, and some people think of the cloud as, hey, I know this. That's just the mainframe era. I already lived through that, right? We put computing up in the cloud, and we all share that. But really, infinite computing is the inverse of that. It's not about having this limited resource that we all share. Think of the opposite. Instead of having one computer that we could do a 10,000-second simulation on, in the cloud today, you can rent compute power, and it's dedicated to you. And the economics have changed. This is a real big disruption that's happening here, because if you've got some kind of simulation, visualization, analysis that you want to do, you can use 10,000 computers to do exactly the same amount of work in 1 second. And the beautiful thing is, since you pay by the core hour, it costs the same. You have tremendous productivity gains for the same cost. And that's going to change how the whole design industry works, because when you can use 10,000 computers in parallel, you're going to behave differently. Traditionally, we do a design of a part, and we try to lightweight it, make it strong enough, and we could vary the thickness or the width of the part, and we'd design it, and then we'd have a computer simulate it and find out if it was going to perform or not. But we can invert that problem and do the simulation first and have the simulation inform our design. And you do that through infinite computing, where instead of using one computer, one simulation, we can do hundreds of computers doing hundreds of parallel design alternative simulations in parallel. In fact, we have one of our researchers at the Idea Studio who's been doing just that. This is an example of several different buildings where on several parallel computers, different parameters are being used for that design. That's not part of my presentation. That's the hotel sound system. All right, so you can see this, and they actually call this evolution. And instead of having evolution in the real world, when we have thousands of computers running in parallel, you can really do virtual evolution. This is another researcher we're working with who has run 25,000 simulations. And it's like taking two buildings, and they have parameters, not genes, but parameters. Window size, orientation relative to the sun, how much insulation. You let two buildings have sex with each other. They have children buildings. Those children buildings go through a simulation and perform. The best performing children buildings are allowed to procreate and create more offspring. The other ones are killed off, okay? And you go through and you get evolution at a large scale. The computer is starting to help aid you in the design process. Now, the frontier of best solutions is where the blue squares are, on the edge of that curve. And it's our job to be the artist, to be the designer, to pick which along the curve of optimization, operational efficiency is the best. And the result, when you bring the computer into the design process at this massive infinite computing scale, is you get organic type designs. This is the result of that optimization that you see. It looks like something nature would have produced. That virtual evolution is also happening at a small scale. There are people who are taking virtual bacteria, computer-simulated bacteria, with virtual DNA and running virtual evolution on them to create new materials. They have bioplastics and biorubbers, and they've gotten bacteria where they're using virtual DNA through virtual evolution to come up with a thin film bacteria that makes a kind of combination of plastic rubber. Okay, it's a material that we couldn't make any other way through heat, beat, and treat manufacturing processes. So this biocomputation, there's people also talking about programming DNA so that we plant a seed to build a bridge. That bridge would build itself through a living organism, through DNA computing. And being able to simulate that through infinite computing is part of that. Now, the next disruption that is a result of the previous ones is this idea of using visualization, simulation, and analysis. You know, for 20, 30 years now, we've had the technology to do lots of different types of simulations. But they're getting more sophisticated. It's just like my question before. There was a phone, and now there's a phone. And there is a difference. And the same is happening in the simulation space. Whether we simulate airflow, or lighting conditions, or sustainability, the kinds of things that we can simulate are getting to the point where the computer can aid us in the design itself. Here you have a researcher who is defining the basic structure of this tower, of this office tower, and the computer is selecting the most optimal core services, where the elevators go, where the HVAC systems go, all automatically in response. Again, using simulation technology in real time, always on simulation, always on analysis while you're doing your design. You can even see this convergence between multiple industries happening. Some of the things from the video game industry are now converging into the design and construction and building industry, where you have the artificial intelligence characters from, say, a video game being applied to how people would evacuate a building in a fire, for example. Or using simulation as a way to communicate. Now, Parsons Brinkerhoff did this simulation, this visualization of an earthquake. In Seattle, the public vetoed a bill to fund a retrofit of this structure. After making this video public, can anyone guess the next year what happened on the ballot measure? It passed very easily. A very powerful way. Simulation is a very powerful way to communicate. And this trend of being able to simulate and analyze, when combined with infinite computing, we're getting to a point where we can have always-on visualization, always-on simulation in real time while you're making design. So here we are in the car doing a cutaway, making some modifications to the shell or shape of that design, and seeing how it affects the wind tunnel analysis all at the same time. That is going to have a dramatic shift on the process of design. This is also happening at the nanoscale. Using the simulation technology, instead of simulating big things, we can simulate how individual atoms and molecules interact with each other. And in fact, we're seeing things, this is an example of DNA. Not DNA as an instruction set that you put into a cell, but DNA in solution, in a saltwater solution, just floating around by itself. And the neat thing about DNA is you could put charge on it. And when you do that, the red areas are charged. Those charges attract and repel, and DNA self-assembles. It can make structures. So down on the bottom, you're seeing DNA that has self-assembled into gears and springs and triangles. Okay? So when you can simulate these things, you can design nanoscale machines that can change the behavior of the products that you build and design today. And we think in the future, and this is an example here, on the top is the CAD model of what was desired, this capillary tube system to draw in moisture and stuff, and on the bottom is a scanning electron microscope looking at DNA that assembled itself. It was not manufactured. And I think in our lifetimes we're going to see the whole concept of manufacturing turn upside down when things assemble themselves rather than be turned on a machine. And that brings us to the next and final main trend, which is the ability to go from the digital world back into the analog world. Okay? Now, one way to bring the digital world to the analog world is through visualization. This is an example visualization that takes a very detailed digital model and makes it seem almost real. Again, a great way to communicate and collaborate with non-technical people and involve your customers in the innovation process itself through this ability to bring that digital model into a more analog form. Anyone tell which one of these is real? And it's a trick question, because they're both fake. The one on the left can be generated at 60 frames a second in real time. The one on the right takes a couple hours. Skin is really hard to model, but we can do that today. And you can even take digital experiences and you can bring them into the real world. Parsons Brinkerhoff is taking the digital model into the real world through this driving simulator. We saw this last year for those of you who came to Autodesk University.
Tom is obviously texting while driving.
So that's just another example of bringing that. But probably the most profound and probably the biggest disruption that's going to happen in the digital to analog world is around 3D printing. This is a 3D printer or a rapid prototyping machine, and just a few years ago, it cost about $250,000, okay, to have one of these. The technology's been around for a while. It was an invention, but not an innovation. It's now becoming an innovation. You can get this democratized version of that product for about $600. You can get a 3D printer, a desktop one. It prints one type of plastic. It's very inexpensive. And what's the first thing that you print on a 3D printer? There's another 3D printer. This printer can print 75% of its own components on the printer itself. By the end of next year, the open source community who's working on this hopes to get to 95% of the components can be printed on itself. Okay? Now think of what that means for manufacturing. In the future, you're not going to stand in line at the Apple store waiting for the next iPhone to come out. You're going to print it at home. And if you think this is funny, this is already happening on many scales. We can print over 50 different materials today. As a matter of fact, I heard from somebody just at the beginning of this conference saying that the actual number is up to 75 now. 75 different types of materials can be printed on a 3D printer. Okay? Think of the music industry. Music industry used to be about manufacturing vinyl discs that were in a distribution network sold at retail stores. And that all changed. Manufacturing could go through the very same thing. When people have home 3D printers, they're going to print the manufactured stuff at home. And so what is the value in the music industry? It's not in the physical good. The value in the music industry is the intellectual property. It's the song. It's the data. And I think the same thing is going to happen in manufacturing because the complexity is free. The 3D printer doesn't care if it's printing a Lamborghini or a Camry. It costs the same to print either one. The complexity is free, just like on a 2D printer. And I talk about printing a car, and you laugh, except for the fact that that's already in the past. That's already happened. Irby has printed a 3D car. Okay? Did you know about the 3D printed organs? I went to the TED conference earlier this year, and we're not allowed to show the pictures because TED is very protective with their things. But let me say that they had an inkjet printer technology that printed not inks in 3 dimensions, but it printed stem cells and a calcium lattice. And it prints and stutters those stem cells onto that calcium lattice in layers, and they put that down into a solution, an oxygenated solution that the stem cells grow in, and you can grow organs. And they printed a 3D kidney in 3 days. They brought out a student who had bladder cancer and would have died had they not printed, using his stem cells, his DNA, a replacement bladder, implanted it in him. He walked out on stage perfectly healthy to live the rest of his life. That organ will not get rejected because it was his DNA, his stem cells. So this is already happening. Okay? Now, when you think of people having 3D printers at your local mall, printing out your tennis shoes, or maybe in your home someday, it means that manufacturing is going to change, not just in how we make and how we get our products, but the fact that we don't need to do mass production. Not everything needs to be the same. We can get back to the master craftsman days before the Industrial Revolution, but at the price point that's even cheaper than the Industrial Revolution because we don't have to transport, warehouse, and put on the Nordstrom rack the stuff that didn't sell, right? Just print what people actually want when they want it. And so here's Bespoke again, where you could see no two of their 3D prosthetic devices are the same. They're all individualized. And that's the future, I think, is personal manufacturing. Now, a lot of the presentation I've been showing you this ability to capture DNA scan, the ability to simulate at the nanoscale and micro self-assembling materials like DNA and things like 3D printed organs. This device is a printer. This is a desktop 3D printer that, anyone guess it, what it prints? And you can see the iPhone. You plug your iPhone in, and it prints DNA. It's a home desktop DNA printer. This is coming. This is going to change everything. This is the reason why we're going to print, a seed that we plant that builds something. Now, if you're in the architecture industry, you're thinking, oh, he's just talking about manufacturing. This isn't going to affect me, except for the fact that at the University of Southern California, this professor, Kashnevis, is already printing 3D buildings. He's scaled up the technology to print an entire building. Okay, there's a grad student standing next to a wall that's being printed. They take concrete, they embed in it things that are similar to carbon fibers. It becomes super strong, stronger than any concrete you know, and it's 3D printed into any shape, all automatically. So what happens to the construction industry when we don't have construction? It's just like the music industry. It's dramatic opportunity for change. We can also bring the digital world into the analog world through things like augmented reality. Taking a BIM model, for example, taking live video from a tablet and blending the two together to show what is possible or show extra information over top of reality. We have BN Builders who's doing this today. They have a tablet here, and in the big picture is what he's seeing on the tablet. In the small picture is what's in the actual room. You can see how these two things come together as a live augmented reality system. Now, those are the 5 major technology disruptions that I'm following that I really think are going to revolutionize the entire design industry. But there's actually a meta trend, a 6th trend, and that's what I call the network effect, which is bringing all these other trends together. They're really a progression because while these are individual inventions that have happened, the real innovations happen when you start to mix and blend. The same way that you don't buy music disc anymore, you mix and blend your own song, your own strategy out of this. And that net effect is happening through those trends. It's the internet. It's also the social net or whole system design or the always-on mobile networks that are out there. So there is this kind of meta 6th trend, which is the network effect. And to demonstrate that, this is an example that comes from Google. I got to experience this at the TED conference. It's Google's self-driving car. And if you think of my 6 trends that are affecting design, this one device incorporates all 6 of them together at the same time. The capturing reality, it's got a laser scanner on its roof. The going to the cloud data systems and leveraging the cloud for roadway and traffic information. It's got infinite compute passability because it's tapping into the cloud, infinite computing systems, and what's in the car. It's got the ability to do the ultimate in analysis and simulation. And finally, it's the ultimate in digital to analog reality. Have fun.
Exactly. You're right.
Alright, I am gonna have my hand near the steering wheel, foot over the brake, but I shouldn't. You get to hold the keyboard, so don't.
That car is now driving itself.
Yikes! God, we're gonna flip it.
Now, how's that for the future? It's already here. That car has driven 600 miles up the California coast. It's gone all the way up to Oregon. It went over the Golden Gate Bridge. It stops at traffic lights. It waits for little old ladies to cross the road. Okay? It avoids animals. Okay? It picked a toll lane on the Golden Gate Bridge. It went through the Mount Lassen Pass when an 18-wheeler tractor-trailer was coming around the other way on a sheer cliff, and it picked its path and went through. Okay? The future's already here. These are the 6 trends all coming together, and it starts with that reality capture on the roof there. Now, with that, in summary, we have these 5, say 6 technology disruptions that are creating opportunities and potentially headaches. Now, your question is to figure out how you're going to respond to these. We're seeing these technology disruptions happen at many scales, from the very small nanoscale all the way up to the global scale. We're seeing this convergence of different types of data coming together through BIM and digital prototyping, but we're also seeing a convergence of disciplines, different types of people working together. It's not throw it over the fence to the structural engineer or it's throw it over the fence to the manufacturing team. It's really converging these things together. And we're seeing this ultimate democratization in cost, ease of use, and accessibility of this technology, so that to stay ahead, you have to move even faster now, because even your customers can start leveraging some of this technology themselves. So you have to redefine where your value is, maybe the same way the music industry did. So to transition back to John's strategy thing, just because there is a technology disruption doesn't mean that it's part of your strategy. Strategy really comes down to your corporate culture. If everyone used technology in the same way, it wouldn't be strategic. You have to find your differentiation. So the question for you, and later today, is to figure out where the balance is for your company, what your culture is, what you want to be different at. And remember where the maximum value attained in this curve is, and also remember that if you are going to use technology as part of your strategy, you need to invest in it when it's still somewhat impractical, when it's an invention and you're going to make it an innovation. Now, if you choose not to use technology as a strategy, you still need to respond to it. Eventually, it will become expected. And with that, I'd like to come back to John, who is a designer himself, to relate these technology disruptions back to the design process. Thank you.
Thanks. Well, I hope you were inspired by Brian's comments, and I hope maybe you were a little scared too. You know, in some sense, when you see this kind of thing from Brian, the two reactions I have are wow and uh-oh. So as we think about this, I think we need to think about how they relate to this question of innovation. If you remember when I was up here before Brian, I said we have to always be thinking about both sustaining innovation to stay on that curve, to stay on that productivity curve, but also breakthrough innovation to move beyond it. And some of the things Brian talks about are relevant here. We have to leverage some of these things. They will happen. We have to leverage them to stay on the productivity curve through sustaining innovation. We have the opportunity to use breakthrough innovation to jump ahead of the curve. Now, each of these kinds of innovation, we have to do each of them, but they have different mindsets associated with them. Breakthrough or sustaining innovation is really about optimization. So it's about taking an idea, tweaking and tuning, measuring, seeing how it works, and tuning it at a fairly low level. Breakthrough innovation is a little different. It's more entrepreneurial. It still goes through a trial and error process, but it's really around, does the idea work? The experiments are at a more gross level, a bigger level. So it requires a different kind of thought process. To some people it looks undisciplined, to others it's highly disciplined, just a different kind of discipline. So if you think of both of these kinds of innovation, they have different mindsets. Sustaining innovation requires a high degree of discipline. Breakthrough innovation requires vision, requires the ability to see or to think about something in a new light. Sustaining innovation tends to happen at the center, tends to happen in the area we know. Breakthrough innovation happens at the edge. We look outside to find things that happen there. Sustaining innovation is about perfecting and tuning the past. Breakthrough innovation about creating the future. And finally, sustaining innovation is about optimization, and breakthrough innovation is about imagination. So each of these forms of innovation is something we all have to do as strategists. But how do we do this? Particularly, how do we do the breakthrough innovation? Generally, businesses that are successful have a pretty good handle on sustaining innovation because we've taken our business, we've scaled it, we've tuned it. The place where businesses often have a problem is through breakthrough innovation because in some sense, it really threatens the old norms. It threatens the existing business. As Brian mentioned, I'm a designer. I have a design background. And so we've thought a lot at Autodesk about how design relates to innovation. We actually believe design and innovation are integrally linked, intimately linked. In fact, Brian mentioned the idea of invention and innovation, which people often get confused. Invention is about the creation of an idea. Innovation is about taking that idea to reality, to make it useful for society. And we think design is actually that bridge between invention and innovation. Design is the set of skills, practices, and methods that create innovation from invention. And I'll explain that in a minute. So how many of you, I can kind of see out there, just raise your hand, how many of you had one of these MP3 players at some point in the past? A few. And did it work for you? Worked for you. So it played songs, worked fine. Any issues with it? Any issues with it? No problems? Do you still have it? No, okay. Yeah, so these were very popular around 2000. But they're pretty much gone. What happened? Anybody? The iPod, right. The iPod came out and completely wiped the MP3 players off the face of the other MP3 players off the face of the earth. So what made the iPod successful? Any ideas? Simple? Design? Content? Other thoughts? iTunes? Capacity? I heard something, I couldn't tell what it was. Oh, innovation? Well, yes. Value chain? Easy to use? I couldn't hear that one. Cool feeling. Okay, so the way you actually felt. Well, and the truth of the matter is, you're all right. It was all of these things. It wasn't, people initially thought, oh, it's just a cool object, and it was, but it was much more. It was about the compatibility with the PC and the Mac, iTunes. It was about the digital rights management system that lets you break albums apart. Brian talked about the LP that was 12 songs bundled on a record. A big issue for the music industry was breaking it apart in the 99-cent song and the ability to manage digital rights. All of these things, the Apple brand, the Apple Store, all of those things created actually a business system. So it was the design and the innovation, but it wasn't just the thing. It was about the entire business system. I'm reading right now the new biography of Steve Jobs by Isaacson, and it's very interesting to read it. This is actually some stuff that I teach from, but now reading the story, turns out there's a lot more detail behind this than you might have thought. He was very actively negotiating with musicians in the music industry, and he saw what had happened in the music industry. And so the whole discussion around disaggregating the music industry and reconfiguring it was something he very actively drove personally. So interesting read if you want to know more about this. So the business results were pretty good. Usually I ask my MBA students if these are good numbers. This is the intelligence test for them. The financially oriented ones usually are the first to raise their hands. So they're fabulous numbers. If you look at what happened from a business standpoint, the iPod reinvigorated Apple, created a whole new line of business. I'm sure you all know that Apple is the number 1 or number 2 company in the world by market cap, depending on the day right now. So a phenomenal business result coming from design, but design in the broad sense, not in the narrow sense. So I think what really made the iPod and later the iPhone, the iPad, a phenomenal success was design of the business system. It wasn't just the design of the object, it was all of these interconnected things, all of these components and activities. So Michael Porter, who I referenced earlier, talked about sustainable competitive advantage coming through a tightly integrated and linked set of activities that reinforce your strategy, reinforce your business. This is someone's attempt from the University of Toronto to actually show Apple's set of activities. So it's a map of the things they've done, and they've created these things and very tightly interlinked them. So when we think about design, I think one of the challenges for those of us in the design world, including many of you, is our customers often think about design very tactically. They think about design as a stage in the development process, whether that development is of a building or of a product or of a movie. They think about it this way, as a point here. And that notion of design tends to gravitate toward form. It tends to gravitate toward the beautiful object. And that's a reasonable definition of design, but it's a definition that really kind of focuses on form and trendiness and fads. So it's a very transitory definition of design. In some ways, it's about design as a noun. It's about the design as a thing. And that's useful, but design can be so much more. I like to think about design far more strategically, as a verb, so as spanning the whole value chain. So another example might be the Amazon Kindle. Think about the Kindle, and now there's a whole proliferation of Kindles, Kindai. But they all kind of work the same. I can read a book, my Jobs biography, on my iPad, and I can look at my phone, and it syncs to the phone. It knows all the content, so there's a whole ecosystem back there that's all integrated. Amazon knows what I bought. They know what my friends bought. They deal with customer service in a fairly interesting way. So all of this is around designing a business system. So when we think about design, we need to think about design broadly as a verb and as the design of a business system. So if we take the kind of things we've learned about design of objects and expand them to design of systems, I think that's the key to creating this breakthrough innovation. If we kind of follow 3 basic things about design, one is to look at it from the user's perspective. So if you think about the technologies Brian talked about, think about them from a user perspective. Learn through prototyping. So we learn through experimentation. If you go back to that breakthrough innovation idea of really trying to iterate on an idea, that's really what prototyping helps you do. And finally, bringing together multiple disciplines and perspectives. I think one of the things we see with the technological richness that Brian described is that problems are becoming more complex, the world's becoming more complex, And through design, we can actually bring together lots of different perspectives and expertise. So design as a verb is about these three things and more. And again, it's about thinking about the entire business system, not just the thing. So I hope you've seen that we have these two kinds of innovation. They require different mindsets. Both are important. And through some of the things Brian talked about, I hope you've seen that you're going to have to respond to some of these technological trends through sustaining innovation, just to keep yourself on that productivity curve. But you also have the opportunity to leverage some of the trends Brian talked about to do breakthrough innovation, to move off the curve, to create sustainable competitive separation for your company. Because ultimately, that's what our job as strategists are. So the things Brian talked about can be daunting. It can sometimes feel like we just have to surf as fast as we can to stay ahead of the wave. And there certainly is a risk that we will be eclipsed by the wave. But there's also the opportunity. There's the opportunity to create new breakthrough innovation, create new competitive separation. Because ultimately, all of our jobs are to create these two responses. Wow, from our customers, uh-oh, from our competitors.